Yeah, hello everyone, good morning. I will talk about how we at Altair believe that generative AI and AI in general reshapes our very own industry. So a couple of months ago, I have heard a talk by McKinsey, and they actually claimed that AI is kind of the fourth platform revolution after personal computing, after the internet, and after social media, right? So, and there's for sure a lot of hype around generative AI, and yeah, but when we talk to our customers, what we find is that most people actually think about generative AI as this, chatbots, right? But is that really everything? Well, the fact that many people equate generative AI with chatbots is actually a shame. It almost feels like people have this powerful space laser now, and actually all they do is they replace their old rusty hole puncher with it, right? But actually, generative AI is a lot more than that. And we would like to look at this a little bit and see how this really shapes our very own industry. So let's have a first look at what generative AI can do. This is an overview of the categories of models from Hugging Face. So, and what you can see is chatbots is basically in this text generation bucket over there. So this little orange thingy there. But what you can see is that there are numerous more categories, right? But even in this red box alone, there are like thousands, dozens of thousands of models. And in the other categories as well. So beyond text generation and chatbots, there are numerous other models for cognitive tasks, and there are numerous other models for other generative tasks. So, well, let's dissect a little bit more what generative AI does for, well, how we manage data, how we work with data, and how we analyze data. Well, we believe that generative AI will really change everything. And I'm going through 4 examples of where we see generative AI changing things in the data analytics space. The first one is generative AI disrupts how we do analytics and what we can do with analytics. And generative AI will completely change that, and I will go through a tiny example, basically, that just gives you an idea of how that will change, basically. And the second one is generative AI will further democratize AI. Why? Because it makes it simpler. There will be new interfaces powered by generative AI that just makes analytics much more accessible, and hence, it can be more widespread throughout the organizations. And third, data and AI, so kind of data and the methodology will grow closer together. And there we will look a little bit at how that is, coming to life and how that is really supported. And last but not least, and that's even more of a hype topic these days, agentic AI, right? So generative AI can not only like pull information together, nowadays it can also act. It can execute actions, basically, right? And I will also we can talk about this all day long, agentic AI, and what the impact of this may be and what the possibilities of this may be. But I will really just talk about this for a couple of minutes to give you some idea of what it really may entail. So let's start with the disruption of analytics as the first topic. So a few examples of how generative AI disrupts data analytics. First, well, let's look at the typical things that you would do in data analytics. You would ingest your data, you would pre-process your data, look at your quality, figure out how good the data is, prepare it basically for modeling, enrich it potentially, and then do machine learning on top. So data quality, how could that benefit from generative AI? Well, Traditionally, things have been done using statistical algorithms or like rule-based analysis of data, where it goes through the data and figures out, okay, there may be some outliers in there, this data may not be as plausible. But nowadays, generative AI has a lot of knowledge basically just baked into models themselves. That's why we call them world models, because they know a lot about our world. And I will just go through one example how that can be used to identify potential data quality issues. Data engineering, such world models have almost like lexical knowledge of the world. They understand a lot about the world, context about the world, and connections, so we can use that to enrich data based on what you have in your data, right? You basically just explore those aspects of the world model and basically bring in new information. And lastly, machine learning. Well, there you can also do a lot of things and in a better way because you can leverage those pre-built models basically and the information that is contained within, right? So you don't necessarily have to build a custom specific model for whoever is going to churn in the future, but you can basically try to use all the information contained in those world models to infer potentially who is going to churn. Right? So let's just look at one of those examples in a little bit more detail, and that is an outlier detection example. So let's assume we have a data set, may look like that, where you have some data about people, right? So first one, a CEO owning a Porsche, living in New York City, and owning a salary of whatever. Right? Then a software engineer and a janitor owning a Volkswagen. Well, let's think about how a traditional machine learning or a statistical model would sift through those data to figure out outliers. They would basically look at each rows, at all of the rows, and figure out which are statistically different than the others. What they obviously don't know is, well, the meaning of a Ferrari, right? Or the meaning of a salary in context with the cost of living, let's say in Los Angeles, right? This is all information that is not just statistically in the data. It's context that you can apply to make decisions on the data, but context, well, that, again, is not just in the data, but is contained in a world model like generative AI or large language models. So we can just use that, right? So task here would be, okay, find suspicious rows and outliers. And how do we do that? Well, we could simply ask a generative AI model through a prompt like this. Hey, we will describe some attributes of a person, and we want you to think about this person. And here's the person's data, basically. Do you think that those attributes are plausible for this person? Rate this, okay? And then just deliver the number, or a number for the degree, and no prose or additional text, but we also may want to have some explanation for that, right? And this is then what we can obviously do easily for each of those rows and understand, okay, here's the plausibility of 3 or whatever. So how would this work in a tool like ours? Well, basically, you would take all the data, you would load the data, and then you would use basically what we call an operator to send all those data individually through a prompt to machine learning, through a generative AI model, ChatGPT or Gemini or whatever you want to take. And then basically the model comes back with a number of plausibility just as we asked for, right? And this is how you can use like additional information baked into such word models to draw information about the data. Good, so why will generative AI will disrupt analytics? Well, first of all, generative AI is so much more than chatbots. It will completely change how we do analytics just because you have those opportunities of bringing in world models as a context. But nonetheless, there are also thousands of new use cases that you can actually do. Those that you could have been doing with traditional machine learning or statistical analysis or any other traditional means, but also a lot more new ones. And why is this beneficial, basically? What's the key advantage of generative AI? Well, the key advantage is that there is already pre-trained knowledge in those models, knowledge about the world. And that is obviously a huge cost saving, because for a lot of use cases, you don't necessarily need to build a new model from scratch anymore. You can just take one of those that bring this context about the world. So a lot of the data science and analytics work will be just done much faster as before. Second topic, AI democratization. So generative AI will also make it much simpler how we do data management, how we do data analytics, how we do data science, AI itself. How is that done? Well, let's first look at quickly how analytics is traditionally done so far, right? So there are a couple of different, what we call modalities, basically, how you work with data and how you manage data and so on. So you could do this either in code, with Python code or R code or anything like that, in an IDE. You could do this with like visual data pipelines, or you could do this in a more automated fashion, however this automated fashion will look like a wizard or something like that, right? But with generative AI, you can do it differently, and this is basically the way it's being established is you can use copilots. So you can basically ask the tool to do things for you. So as an example here, how can coders be supported? Well, through a copilot for code development, where you can ask, as a user, you can ask the tool to write some SAS code for you, right? And the answer may look like that. Or if you're rather like working in a low-code, no-code environment, then you can do the same for workflows, okay? So let's say we want to have, we analyze stores basically, and we would just want to know which store has the most revenue, then you could ask that basically, and it's creating the necessary data analytics pipeline for you, okay? So again, yeah, generative AI supports users in doing analytics in a better way. So why is that? Well, generative AI basically removes the burden for users to learn specific tools. They can just interact in natural language, which they obviously know, with the tool and ask the tool to do things for them. Yeah, this will work for all the existing modalities, and we will see basically assistance to support all those different modalities, whether it's coding, whether it's visual pipelines, more automated things. But there will also be completely new modalities of like interacting with the tool. And again, yeah, this will boost the productivity of people. That's number one, working with data and doing analytics. Currently, it's mostly focused on the development side of things, but we will also see that throughout the entire data analytics process, from data ingestion down to model deployment, running machine learning operationalization, and so on. Third, now we have pointed out one of the big benefits of generative AI models is that they have this world model context, basically, right? That they have a lot of information already about the world. What about if we want to include more specific knowledge, more specific content? Data that may not be lying within a world model. Obviously, all of you working in a company, you have proprietary data, and you have some data that you may want to include, I mean, should include in your analytics to draw the necessary conclusions for your business. How do you do that? Well, the best way to incorporate all of that is through knowledge graphs. And I will come to why this is best. But before, let's quickly go through what a knowledge graph is. A knowledge graph is basically a graph organizing information. And it typically starts all with an ontology. And an ontology is a semantic model for a domain. Let's maybe look at a quick example to make sure that we all understand how this works. So let's look at the film industry as an example. So in the film industry, you may have classes. And classes could be, for instance, an actor or a film or a director. And then typically those classes have relationships between them, like an actor acted in a film, Or a director directed a film, and then is the acted in or directed is the relationship between those clauses. Second, both the relationships as well as the classes can have attributes. So for instance, for a film could have as attributes like the name or the year of the release, and obviously actors or directors could also have a name or a nationality as an attribute. So this is kind of the ontology. That's the semantic description of the world, basically. And it's kind of similar to how you would model data in a SQL database. Okay? Now, a knowledge graph is the ontology plus all the data that you have. So plus all the instances within that data. So as an example, a part of the knowledge graph, an example data in the knowledge graph could here be Tom Hanks acted in Splash. Right? Or Tom Hanks acted in Forrest Gump. Okay? And all that data together basically forms the knowledge graph. Now, why are knowledge graphs so important and beneficial? First of all, they allow to connect data from a lot of different sources quite easily. And that obviously removes data silos in an organization. Second, they are quite simple to access, and they allow access to complex data. And that includes both unstructured and structured data. Okay? So you can easily kind of sift through documents as well and pull entities and relationships from those documents and also put them into a knowledge graph. And hence they can easily kind of contain both structured as well as unstructured information. Then knowledge graphs allow to improve communication. Why is that? Because typically in knowledge graphs, you model data in business terms, not data terms. And that's also how you access the data. So you don't ask like, okay, select star from whatever table underscore something, but you just say, hey, select star from actors or something like that, right? In at least a query language that you would typically use for such knowledge graphs once you access knowledge graphs. So basically, it uplevels the communication and provides kind of a shared understanding of data and like business entities really in an organization, as you basically talk about data in business terms, not data terms. And then knowledge graphs make it quite inherently easy to do complex analytics. So we have a lot of customers, like in the pharmaceutical sector or so, that have very deep investigative use cases. So if there's a problem, let's say with a pharmaceutical product, then companies often need to sift through their data quite deeply, like going all the way through production charges and like research data and so on to figure out like, okay, could this be a justified problem or not? And to do that, you need to basically combine all the data together. And that is quite complex if you're just looking at SQL databases organized in tables. But graphs, they can do that quite well because they connect all the data. They can connect it all together. And lastly, knowledge graphs are kind of the ideal companion for generative AI because they provide data in a format that generative AI models can really understand super well, so you can use knowledge graphs and data contained in knowledge graphs to basically ground AI and feed more information into those world models to add context at hand that you have in addition to the world context. So how could this look like? Something like that. So for an enterprise, you could basically connect all the data, like engineering data, product lifecycle data, data from your machines, your factory floor, after sales data, and connect them all into a knowledge graph. And then you can effectively ask questions to the data, just as like in this Google type form. How many gluing machines are there in the plant in Warsaw? Well, then basically, goes through all the data and pulls like what it needs to provide that information. Just a quick example here from a demo with respect to this film domain that I talked about earlier. So maybe you can just ask it, basically, can you show me the details of a specific movie, right? And then obviously pulls that data. So that's quite simple, right? But then you can also go deeper and ask, okay, list all those actors who performed in that movie. Well, also still quite simple, right? I mean, obviously, if you have SQL databases, you can also kind of do that. But then you can obviously do more than that. So here we have kind of a Copilot interface again, where you can ask in natural language, and it basically translates that into a query language that actually then queries the knowledge graph. But there you could also do things like that. Hey, okay, please compute the average age for these actors. I have not specified in here like which these actors are. It kind of references like from the conversation above, okay? And then it basically calculates the average. So this is kind of a way how you can interact with the knowledge graph in a Copilot interface, again, making things simple for users because they can easily work with natural language, but then basically pull all data in an organization in business terms. So how will generative AI will help data understanding here? Well, basically, knowledge graphs allow semantic modeling of data and easy access to all data within enterprises. They provide context to generative AI models, which is quite important if you want to feed in like additional information into generative AI models. Then, obviously, generative AI can help further simplify the access as well through Copilot interfaces. And ultimately, both together, generative AI and knowledge graphs, kind of turn raw and siloed data that you typically have in an organization into pervasive understanding of a business. Okay, fourth, and I promise to really just be very brief on that one, so I only have one slide, agents. So generative AI can pull a lot of information together, right? But nowadays, it can also reason and use tools to perform actions. How could that look like? So basically, it could look like that, well, as part of a prompt where you pull information, you also allow the large language model, the generative AI model, to, let's say, execute a Google search in addition, right? So that would be a tool it can use, okay? But you can think this much further. So let's assume it could also create a lead in Salesforce for you. Then you basically ask the generative AI model, well, go through my LinkedIn account and figure out the most potential leads that I should contact, right? It does that kind of automatically. It goes to LinkedIn, it pulls your contacts, and it rates them, and then basically it automatically puts them in Salesforce as a lead. This is something that an agent could do for you, basically, right? Now, obviously, it could do that based on your request, but it also could do that fully autonomously, right? This is kind of the vision that we see for agents, and there will be so much more that this can do. Again, we could talk about this for hours here. So my last slide, I would want to end on this note here. So we see that generative AI will really change a lot in how we work with data and how we analyze data. So what we see is kind of a new architecture paradigm emerging within our customers. And that is basically employing the combination of a data fabric, which means everything around like managing data, working with data. An AI factory, that means like creating AI models and like pulling information from AI models to, or from data to make decisions. And this combined thing is greater than like those two things separately. And that's what we call an AI fabric. That's basically where all those methods that I've talked about come together, and where really generative AI helps you to take really the best from your data and make the best decisions for you in a ideally very automated way. And that's all I had for you today. Thank you.
Thank you, Tobias. Thank you, Tobias. Any questions? Now or never? Yes, we will send them.
Yes.
Hi, thank you for the nice talk. Basically, like one of the problems of general data science is that it tends to be sometimes black box. And as you mentioned, like here, that like with AI and generative AI especially, we are going like even further in that space. So basically, my question is, how do you evaluate? How do you measure that the things you talk about here really work in the real world?
Yeah. No, you're absolutely right. I mean, unfortunately, generative AI models in itself are kind of even more black box than traditional machine learning models. Why? Because they are way less understandable, obviously, right? I mean, if you really understand what they do, kind of deep learning models with billions of neurons, basically, it's like super complex and nobody will understand that, basically, right? And even the people who built this will not understand exactly how a model works. So hence, it's even more important to basically implement things like machine learning operationalization or large language model operationalization, agent operationalization, where you basically trace like how the models make decisions, what decision it makes, and run this kind of against test cases, test scenarios to really understand, okay, in this scenario, it's making this decision. In this scenario, it's making that decision, right? So validation, evaluation, monitoring becomes even more important than in traditional machine learning.
Well, thank you. Thank you. Because we are running in time. Well, next questions, you can meet Tobias during the coffee breaks.